you had learned what a quadratic is, we then taught you how to solve for one. So let's start just by solving an equation that's not a quadratic. So looking at this top left-hand equation, I would need to move my variables to one side. Oops, equals. Move my numbers to the other side by doing opposite operations here. So 3x equals 30, divide both sides by 3, and I see that x equals 10. So I could plug that 10 back into each of these, and I would check it to make sure it works, and 10 would be my answer. So let's do that again, but this time with a quadratic equation. So 5x squared plus 4 equals 49. So let's, again, work backwards. I'm going to subtract 4 from both sides. So 5x squared equals 45. Divide both sides by 5. X squared is equal to 9. Then I would take the square root of both sides, so x equals both 3 and -3. There's my two answers. Cool. Okay, so here's another example. X squared minus 2x equals 8. Here's where the problem happens. Okay, because I have the x written twice, I cannot just work backwards the way that I did the last two problems. So here's where we learned a bunch of other methods to help us solve this equation, because there is a number for x that will work to where this equation will equal 8. There is an answer. We just can't solve it using the methods that we have learned in prior grade levels. So we learned that there are 5 methods. There's graphing, factoring, square roots, completing the square, and the quadratic formula. Most of these will work most of the time, but every now and then you have a problem that really just doesn't lend itself to one of these methods. And we'll talk about that as we go through them. So first is graphing. Graphing works 99% of the time. What I do is I move this 8 over onto the other side. So x squared minus 2x minus 8 equals 0. The reason I want it to equal 0 is because that tells me that I am looking for coordinates where I've got an x value and then 0. Well, those are my x-intercepts. So looking at my graph, I can see I've got one here at -2, and then I've got one here at 4. So I know that that looks like a coordinate. I shouldn't write it that way. -2 and 4. So I know that my answers for x are both -2 and 4. Okay, so again, there were answers, and I could plug both of those in for x and test it to see if it really does equal 8, and it would. But again, that was a quick and easy way to do it. You just have to set it equal to 0, and then graph it and find the roots. Okay, that's our first method. Then we talked about factoring. Factoring, again, requires you to move that 8 to the other side so that it's equal to 0. Then you use your skills of factoring. So I'm going to do the x factor here. So what multiplies the -8 and adds the -2? I'm thinking it has to do with 4 and 2. My 4 is going to have to be negative. Now, here's where some of y'all confused the trick and the shortcut with the answers. And that was something I want to make sure we clear up here. This -4 and 2, those become my factors. -4 is x minus 4. The positive 2 becomes x plus 2. But this all equals 0, right? We talked about how if this times this equals 0, then one of those themselves has to be 0, or both. So I'm going to write x minus 4 equals 0 and x plus 2 equals 0. So I'm going to add the 4 over, so x equals 4. And then I'm going to subtract the 2 over, and x equals -2. Okay, so you'll notice I got the same answers as I did up here when I graphed it, but I just did it through factoring instead. I do want to come back to this in a second and talk about how you go back through this process, but we'll do that at the end. Okay, so same equation. You'll notice I have not changed the equation. Completing the square is a slightly different method. This is where you're wanting to use perfect square trinomials. In this case, I do want to leave the 8 here. I'm not going to move it over and set it equal to 0. Instead, I'm going to find something that I can add to both sides of my equation so that I create a perfect square trinomial. The way we do that is we think, okay, this -2x was the result of doubling something. Well, I doubled -1x. Well, what can I square root to get 1? Well, 1. So let me write that in different colors. So I'm going to add a 1 to both sides. That allows me to factor this side. I get x minus 1 squared. Combine this side, which equals 9, and then I'm able to actually just work backwards. So I'm going to square root both sides. So x minus 1 equals 3, and x minus 1 equals -3. Then I add 1 to both sides, so x is 4. There's one of my answers. Add 1 to both sides, x is -2. There's my other answer. You'll notice, again, we got the exact same answers as we did before, -2 and 4. Okay, quadratic formula. This is the longest one, but this is the one that is a surefire works every time situation. So the quadratic formula is on your formula sheet. You do not have to remember it, but you can always sing the little Pop Goes the Weasel song if you forget and want to know it yourself. But then it's just a game of plugging everything in. Before you do that, though, you want to make sure everything is on one side. So you do have to move the c value back in, or move that 8 back over. So negative b, that would be the 2 value, which is already negative. So 2 plus or minus the square root of 2 squared minus 4, technically negative 2 squared, 4 times a times c all over 2a. Okay, so then it's just a big old game of PEMDAS. So I've got 2 plus or minus the square root of 4 plus 32 all over 2. So that's 2 plus or minus the square root of 36 all over 2. Square root of 36 is both 6 and positive 6, or 6 and negative 6, sorry. So I've got 2 plus 6 over 2 and 2 minus 6 over 2. So if I work those out, 2 plus 6 is 8. 8 divided by 2 is 4. Then over here, 2 minus 6 is negative 4. Divided by 2 is negative 2. Again, same answers as I've been getting this whole time. Remember also that you can use your calculator for this. You can just type all that into your calculator and it should help you out. Okay, now the last method is square roots. And I went ahead and kept that same equation on here, but I'm not going to be able to use it. And the reason why is square roots just means working backwards. This is what I was doing at the very beginning of this video. And I can't work backwards with this equation because there's 2 x's. So I can't show you with this problem because I literally can't. It doesn't work. But I can show you with this other problem. So square roots is just working backwards. So I'm going to divide both sides by 4. So I get x plus 3 all squared equals 25. Then I want to take the square root of both sides. So x plus 3 equals 5 and x plus 3 equals negative 5. Then I move that 3 over. So x equals 2 and x equals negative 8. Now remember, I didn't get the same answers because I used a different problem completely. Okay, so here's some examples of some star questions related to this. I would encourage you on star to just use the graphing function because you can use the gsolve button to find the roots every time, but you can also use that when they're clearly wanting you to do something else. So for example, which statement about g of x equals x squared minus 576 is true? It says the zeros, this and this can be found, the only zero this, the zeros this and this, the only zero this. Again, you could graph this and just see what the 2 roots are and find your answer right off the bat. Okay. However, you can see that they're trying to lead you into factoring because these are all written as factors. Okay. So the answer here is H because this is a difference of squares and it factors into this. But you could also, again, just graph it in your calculator and see that the 2 roots are at negative 24 and positive 24. Here's another one. What are the solutions to x plus 7 squared is equal to 81? Again, they're clearly wanting you to solve this with square roots, and you can. You can go through the process. X plus 7 equals 9. X plus 7 equals negative 9. And your answer here would be G. Oh, no, not G. Ooh, I just made a mistake. Don't make that mistake. When you subtract 7, you get a positive 2. When you subtract 7, you get negative 16. But you could also, again, just use your calculator. And what I would do in this case is I would move that 81 over. So I'd have x plus 7 all squared minus 81, and just type it in that way. Y equals with all of that. Okay. The last star question I'm going to show you is a word problem. And what you have to make sure you understand about these word problems is you're probably not going to realize what kind of problem it is. You're not going to realize that it's a quadratic, that they're wanting you to find the roots. But you have to remember that this is an equation they're wanting you to solve. It says, what is the width? They've given you an equation, they want you to find W. Well, similarly, if I gave you an equation that said 2x plus 9 equals 14, what is x? Well, you would just work backwards and solve. It's the same thing. It just looks more complicated because it's a quadratic. So again, I would just put this in my calculator. I would graph it, find what these roots are, and pick your answer. And I don't know the answer off my head. We could also plug the numbers in, plug each answer choice in for W and see which one does equal 0. But I don't want to waste your time doing that. So feel free to go try this one out on your calculator and see what the answer actually is. But again, you can just graph it and find the roots. You don't want to do the negative one because we're talking about the width of trampoline. We don't want a negative answer. We want the positive answer. Now, before I pause this video, I'm going to go back up to factoring because the other thing that we learned is how to take the roots and go back into an equation, okay? So remember that factoring starts with, well, the problem, but it starts with factors that then you set equal to 0 and then you solve for x. Well, if you want to do the opposite way, let me make up a little problem here. Let's say the answers they give you, the roots, are x equals 4 and x equals negative 2/3. Okay? If those are my answers, I need to move these things back into the x and create the factor. So I'm going to subtract the 4 over and make a factor. And I'm going to do this 2/3 in 2 steps. I'm going to multiply both sides by 3. So I've got 3x minus 2 equals minus 2, sorry. And then I'm going to add that 2 over. So I've got 3x plus 2. Now I have 2 factors. The way you turn it into an equation is then just to multiply it all out. Okay, so I'd have 3x squared plus 2x minus 12x minus 8. So then I'd write that 3x squared minus 10x minus 8, and that would be my equation. Okay, so I just wanted to give you a quick reminder that you can also go back through the process by changing the roots back into factors and then multiplying.